Hello friends, welcome to yet another episode. So first we blinked an LED continuously and then we added a push button to blink the LED. Now suppose we want to blink an LED in every 0.5 second. So this will be our program, right? You can see the output also. But if you add more instructions before and after delay functions, this 0.5 second delay will be changed, right? You can see in this program I have added some instructions before the delay functions. Now we can see the output. The LED is taking more than 0.5 seconds, correct? So this is a problem because for every instruction MCU is taking some time to process that may be in microsecond. So what do we do here to blink LED every 0.5 seconds without deleting all these functions? The answer is timer. What is a timer then? In our first session, we have discussed that there are several components inside a microcontroller. Timer is one among them. We have already discussed about IOs or GPIOs in our previous sessions. Timer unit has got several applications. Like I said before, we can use timer to trigger an event at particular time intervals. We are going to implement that in today's session. If we supply a signal to MCU, then it will be able to measure the signal frequency using timer unit. Next application is we can produce different waveforms and also we can generate pulse width modulation signals. We will be trying some of these applications in our future video. So in order to catch those contents, you can consider subscribing to my channel, okay? For all these applications, timer unit had to be configured in particular modes. In order to generate the time base, we have to configure our timer unit in timer mode. And there are several other modes or use cases like counter mode, PWM mode, advanced PWM mode, input capture mode, output compare mode, 1+ mode, encoder mode, timer gate mode, etc. I don't want to explain all these as I know theory will play well when it comes along with practicals. We will come again here once we are ready to implement all these use cases. In every MCU, we can see different types of timers according to the complexity of functions it can handle. Mainly in STM32 devices, we can find basic timer, general purpose timer. Basic and general purpose timers are available in all the STM32 MCUs. But the third one, the advanced timer, is available only in some devices like STM32G474. For our application, we need only basic timer. Okay, much of theory. Quickly we can go to our project. So launch Cube IDE. So this is our workspace. I'm starting a new STM32 project. We can type our board model G474 nucleo. We can select our board, click next. I'm adding a project name timer. You can keep default settings and I'm clicking finish. Yes, click on yes. Now we have to enable our basic timer unit. So go to timer section here. But there are several timers available. So which is the basic timer here? Now for that we should check the reference manual for that. So Google search STM32G474 reference manual, or you can get this from the ST website also. Before going further, I have to tell one tip. If we are working on any nucleo boards, we need 4 documents. First one is MCU reference manual, then microcontroller datasheet, nucleo board user manual, and nucleo board schematic. We will see its usage whenever a situation comes. So we have our reference manual opened here. Go to bookmark section. Go to the page basic timers. So now we got what we want. We can use either timer 6 or timer 7 for our application because both are basic timers. Again go back to Cube IDE. So I am selecting timer 6 here and we can enable that by checking this box. Now comes the important part, the timer configuration. Before we dive into this, we can have a look at the clock configuration section. We didn't explain much about this, right? This is the most important part of the microcontroller configuration. In order to function any part of the MCU, a clock is required. Basically, it is for synchronization among the peripherals and sometimes with the external world also. The clock decides the speed of processor operations. If the clock speed is higher, the processor can execute its instructions, means our program very fastly. So conclusion is clock is the fundamental block of MCU performance. In all the STM32 devices, system clock or sysclk is the main clock for the microcontroller. CCLK is just a terminology, and this feeds the clock for various peripherals like HB, APB, USB, SPA, etc. HB and APB are parts of ARM communication architecture. So where does system clock is getting this clock? Or what is the clock source for system clock? First one is high speed internal oscillator clock or HSI. It is a 16 MHz clock source internal to microcontroller, but it is less accurate but faster in startup. Next one is HSC or high speed external oscillator clock. As name suggests, it is external to the microcontroller. So we can see this crystal in our nucleo board. Normally we can connect 4 to 48 MHz crystal. In STM32G474 nucleo board, we have a value of 24 MHz. Other than these, we have a PLL clock. It is used to generate frequency more than 48 MHz. So in this nucleo board, we can get maximum 170 MHz. You might have noticed that in our previous projects, we have used maximum frequency for the clock. There are two secondary clock sources used for special purposes. LSI RC is the 32 kHz low speed internal RC. This is used for driving independent watchdog and RTC for auto wake up from stop or standby mode. Then we have LSE. It is 32.768 kHz low speed external crystal, and optionally it drives RTC clock. And the last one, HSI 48. It is a 48 MHz internal clock source to potentially drive the USB-FS and the RNG. RNG means random number generator. It is a peripheral seen in some STM32 devices. Through clock configuration, we are defining clock frequency required for each peripheral in the MCU. Also, we can turn on or turn off clocks for particular peripherals. Why are we doing clock configuration always? When we power on the MCU, only HSI is turned on by default. So all the peripherals will be getting clock from low frequency HSI only. Since HSI is less accurate, for some peripherals we cannot use that. There might be peripherals which needs high clock frequencies. It cannot function in its satisfactory performance if we are using HSI. So we have to use other clock sources to get its maximum performance. And next one is power optimization. If all the clocks are turned on, CPU will use maximum power, and this will affect performance of low power applications. So in that case, we will be turning off unnecessary clocks. How fast or how slow should be our clocks? If clock frequency is too slow, processing will be too low. Or in other way, if it is too high, then there may not be enough time to complete the required operations before the next set begins. So evidently the synchronization will be lost among peripherals. Now we can consider the case of timer. As I said earlier, sys clock is getting the clock from any of the clock sources. Then we have HB prescaler, which will divide the sys clock by 1, 2, 4, 8, or we can use values till 5, 12. We can define this number according to the clock frequency we require. The frequency we get after HB prescaling is called H clock or HCLK. Then similarly we have another prescaler called APB1 prescaler. Then we have output P clock 1 or PCLK1. P clock 1 goes through a multiplier which will multiply the frequency value and finally reaches to timer 2 to timer 7 units. If you are surprised on these data, you can refer the MCU reference manual. You can go to clock section. Here you can see time X and X is equal to 2 to 7. So here we have timer 6. So timer 6 is getting clock after APB1 prescaler. Now we can try some values here. So let sys clock is getting clock from a PLL source. So maximum we can get 170 MHz. So I am using maximum value here. You can define any value less than or equal to 170 MHz. Then AHB prescaler, I am setting that to 1. So 170 MHz divided by 1 will give 170 MHz. APB1 prescaler I am setting for. So PCLK1 we have 42.5 MHz. Then the multiplier value is 2. Now we got the timer clock as 85 MHz. We can just verify this using Cube IDE. So go back to Cube IDE. In the left side you can see all the clock sources, LSC, HSC, etc. We have PLL is our clock source. We can select PLL here. Sys clock is 170 MHz. HP prescaler is 1. H clock we got 170 MHz. APB1 prescaler is 4. Multiplier by default it is 2. So here also we have got 85 MHz for timer clock.